Bing bing bam dum bum bum bam bam bum 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 bum.
What's going on?
Bing bing. Crazy.
The y-axis represents the meters we are from the starting point to where we are running on the track. The x-axis represents the time that has elapsed.
The standard equation for a trig function is y equals a times the trig function times b times x plus d plus or minus c.
The farthest distance we run from the starting point is 200 meters. Half of that is the amplitude, which is 100 meters.
Since the farthest distance we are from the starting point is 200 meters and the closest point is 0 meters, the vertical shift is 100 meters.
The equation for the period in a graph is 2 pi over b. 2 pi over b equals our period, which is 117.19 seconds.
So b equals 0.017 pi.
Also, we know that we have a negative cosine graph because we started a distance of 0 meters from our starting point. Now we know the equation of our graph is y equals negative 100 times the cos of 0.017 pi times x plus 100. Now we start by plotting our y-axis. Since we know the vertical shift is 100 meters, our new x-axis is at 100 meters. Then we also know that our amplitude is 100 meters, so our highest point on the y-axis is at 200 meters and our lowest is at 0.
For graphing our equation, we know the period is 117.19 seconds. So 0 is less than or equal to x, which is less than or equal to 117. Now we know our first critical point is at 0 seconds and our fifth critical point is at 117.19 seconds.
To find our middle critical point, we take 117.19 plus 0 and get divided by 2 and get 58.595. To find our second critical point, we take 58.595 plus 0 and divide it by 2. Then we get 29.298. To find our fourth critical point, we take 58.595 plus 29.298 and we get 88.89.
Since we have a negative cosine graph, our first point is going to be on our lowest point on the y-axis. From there, our points go up, up, down, down.
Finally, we draw a line to follow the curve of our graph.
Now let's see what the graph would look like if it was a sine graph. Let's say we made our first critical point at a distance 100 meters farther than our original point. We would have the same x-axis, y-axis, vertical shift, and period. Since our first critical point is 100 meters away from the start and our vertical shift is 100 meters, we know we have a sine graph. Also, we know it is a positive sine graph because the second critical point is 200 meters away from the starting point. For our critical points, we now know from our first graph that it takes 29.298 seconds to first reach a distance of 100 meters away from the start. This is our first critical point in our horizontal shift. Now we have the equation of our graph, which is y equals 100 sine 0.17 pi times x minus 29.298 plus 100. If we add 29.298 to the period 117.19, we will find our fifth critical point. Also, we can find our d value by subtracting 29.298 from all the parts. Our three middle critical points are the same as the last three critical points on the cosine graph. Now we can graph the critical points. Since it is a positive sine graph, we know our first critical point is on the new origin, and the next critical points go up, down, down, up. Finally, we draw the curve of the graph.